Task 1, Parametric Equations. So in question 1, we're getting an object that moves in a straight line at a constant speed from point 1, minus 13, 1 time is equal to 0, to the point 11, 17, 6 seconds later. So first of all, since we know this is a straight line motion, since we have 2 points, and it does say it's a straight line at constant speed, we have to form an equation on the basis of y equals mx plus c. First, we have to find the slope. So given that the formula for the slope is y2 minus y1 all over x2 minus x1 gives you m. So x1 in this case is 1, x2 is 11, y1 is minus 13, y2 is 17. So if we plug this into the equation, we get 17 minus 13 over 11 minus 1. M equals 30 over 10, which the slope for this given line is 3. So now we have to substitute the slope of x1 and y2 into the equation. That's actually wrong. We have to substitute y1 and x1. So we have y minus y1 equals m multiplied by x minus x1 close bracket. Therefore, equation of the line is y plus 13 equals 3 open bracket x minus 1 close bracket. In the end, giving us the equation of the line y equals 3x minus 16. So that's our general formula for this line for that point. Now we have to build in time. To build in time, we have x equals directed speed, dependent on the sign of the number, such as minus is negative speed, plus is positive speed, multiplied by time, multiplied by x0, where x0 is the starting position if the equation does not begin at the origin, 0, 0. And we have to locate the speed. So the x values in the current guy here starts from 1 and goes all the way to 11. So the difference is 10 units. So given that the equation has to move in 6 seconds, we divide 10 by 6, which is 5 over 3. Therefore, our built-in time is x equals 5 over 3t plus 1. 5 over 3 is the amount of times it takes to travel in 6 seconds. T is the time plus 1. 1 is our origin because it starts on 1, not 0, 0. Okay. Since there are no given delays, step 3 does not have to be evaluated. But if we did have a delay, we just subtract the value of time at the very end. Replace all x values with the equation, so therefore we get 5 over 3t plus 1, and then we have 3 multiplied by 5 over 3t plus 1 minus 16. So we just plugged it into our general equation here. So wherever there's x, we plug in this guy here. And for y, we do the same. So now we have to substitute time equals 0. So whenever we substitute time 0, the points are 113. So that's correct for the first point. And then for the last in 6 seconds, times 6, we substitute 6 for every point. And we get the points 11, 17. So therefore, we located the equation, the parametric equation of the line of these 2 points in 6 seconds later. Okay. Now, question 1, part 2, circular motion. An object is initially at 7, 6. It takes 90 seconds to complete a circular motion of radius 7, about 7.06. So first, we need to evaluate and read through the general circular motion equation. So here we have the equation for the 2 points. So we have a sine, open bracket bt, close bracket, plus c. And for the y point, we have a cos bt plus c, where a, b, c, t are elements of real numbers. So a in this case is the height, amplitude, or the radius. So if I show you this guy here, which is our Excel, we have 3 sine t. So 1, 2, 3. So we get, there. We get a radius of 3, given these points. So Since A is the height, amplitude, or the radius, in our case it's radius, B is the speed or the rate of change, or how fast it will take the points to travel around the circle, and C is our center point, XY. C, for this point, C here is X, and C here is Y. So now we have to substitute the A values. So we have a radius of 7, as given in our question. So for every A in the equation, we substitute 7. So we have 7 sine BT plus C, 7 cos BT plus C. Now we have to find the speed. One full circular movement in 360 seconds will make B equals 1. 1 degree takes 1 second. One circle movement in 90 seconds will make B equals 4, which is 1 degree every 4 seconds. No, other way around, sorry, my bad. It's 4 degrees every 1 second. So in this case, if we divide 360 by 90, we get 4. So that's how we get our speed, our circle, to do it in 90 seconds instead of 300 seconds. So for every B value, we substitute 4. So now we have 7 sine 4t plus C, 7 cos 4t plus C. Now we have to find the correct equation for new center point. So our center point sits on 0, 6. Therefore, for every value of C, we substitute 0 and 6, where in the first part, we substitute the X value here and the Y value here. So it becomes 7 sine 4t plus 0 and 7 cosine 4t plus 6. If simplified down, it becomes 7 sine 4t, 7 cos 4t plus 6. Okay, so if to demonstrate this in our Excel, we have 3 sine 2t and 3 cos 2t, which means 3 is our radius and this guy is our rate of change. So in this case, if we divide 360 by 2, it becomes 180. So it'll take 180 seconds to make the rotation. Okay, so for this guy here, every 4 seconds, every 2, basically it will go up. This entire circle will finish and half the speed, or twice the speed, which means this, to complete 90 degrees backwards, it will take us, hold on, we have, circle is 360, 1 degree equals 1 second. So yeah, so 1 degree will, 2 degrees will become 1 second. Okay, so instead of going up 1 degree equals 1 second, we'll go up 2 degrees equals 1 second, which means we'll finish in double time. Okay, now just to check back on if I missed something. So to create straight line motion, we need 2 points and time. So for this guy here, we need any, it can be more than 2, it has to be 2 or plus, and along the given time, we need the amount of time it takes us to finish that movement. Okay, to create wave type motion, we either use sine or cosine. So in this case, pardon my computer messing up. So we have sine t, which bounces on y value of 2. In this case, it starts at 0, and along that time, which sine of 30, I think it's sine of 30, I'm not too sure. So we are going up in 15, sine of 15, and then sine of 30, then we have sine of 45, 60, and so on and so forth. And it will just keep moving on the line, same line, because we set y to be at the point 2, which means we are moving horizontally. We're bouncing back and forth horizontally. Okay. So for this guy, we have sine t, 5 minus t, which means we're going to grow upwards since we set our y values to have some kind of constant in it, which means it's going to only bounce up. Usually sine waves travel horizontally, but in this case it's going to travel vertically. And to change the center point, as we see here, I think it's the last one there. Okay, should be here. Okay. We have cosine t minus 3 and sine t plus 2, which means our new center point will be minus 3 plus 2, as these are constants after these guys. So as we see here, the x value changed to minus 3, and I don't think you see it, but this center point sits on 2, I think. Sure. Yeah, 2. Okay, these Excel files are messed up. Anyway, in the end, start one direction. Direction, last but not least. Direction is determined by which way you put your cosine and sine. If sine is at the start as the x value and cosine is as the y value, we are gonna move anti-clockwise. So we're gonna start on this point here, 360 or 0 degrees, and we're gonna move backwards in such a way. For shifting it, if we start on cosine as x and sine as y, we will start at point 90 degrees, and we will move clockwise. So our points are going to grow in a clockwise motion. And I'm pretty sure that's everything for today. Thank you.